This is the answer to Chapter 10, problem number 47 from the Smith Organic Chemistry textbook. And this problem presents us with elaidic acid, which has an E double bond. And we're asked to predict how the melting point of elaidic acid compares with the melting points of stearic and oleic acids. And they can be found in table 10.2. I've drawn them here. And so we should remember that melting point is going to be inversely correlated with the number of double bonds. So the more double bonds that there are, the lower the melting point is. And that's because double bonds impact the ability of these long chains to pack together closely. When there's a double bond, the chains cannot pack as closely together. And so, of course, a Z double bond really kind of kinks the chain. And so that's going to have a greater effect than an E double bond would. And so to put these in order here, stearic acid is going to have our highest melting point because it has no double bonds. So then next, between elaidic and oleic, we're comparing an E double bond and a Z double bond. And so the E double bond is going to have less of an effect. So this is going to be our intermediate, the elaidic. So it's in between the two. And oleic will be our lowest melting point. So that's really all that this problem asked us, is to put these in order. And again, we need to remember that double bonds are going to impact the ability of these chains to pack together closely. And of course, a Z double bond will have a greater effect than an E double bond. And so stearic is going to be our highest boiling point. Oleic is going to be our lowest boiling point. Melting point. So stearic will be our highest melting point. Oleic will be our lowest melting point. And elaidic will be intermediate to those two. And that's the answer to Chapter 10, problem number 4.